Hello friends, hello students. I am back with another video today. So today we'll discuss tryptophan metabolism. First of all, I will start with brief introduction of tryptophan. So it is essential amino acid, right? And it contains indole ring. So this is the basic structure of tryptophan, and it chemically it is alpha amino beta indole propionic acid, right? And now, since it can lead to synthesis of both glucose and fats, it is both glucogenic and ketogenic amino acid, right? And now coming on to the products, first of all, it is used for the synthesis of niacin derivatives, that is NAD positive and NADP, right? And secondly, it can be incorporated into proteins as well, being a essential amino acid, right? And further, it is used for the synthesis of serotonin, right? It is a happiness molecule, right? And serotonin can be further converted to melatonin that induces sleep, and serotonin can be excreted into urine as 5-hydroxyindole acetic acid, right? So just summarize, tryptophan, both glucogenic and ketogenic amino acid. Chemically, it is alpha amino beta indole propionic acid, and it contains indole ring, right? And this is the structure, and it is used for synthesis of various derivatives like niacin derivatives, NAD and NADP, incorporated into proteins, and for the synthesis of serotonin, happiness molecule, and melatonin, the sleep chemical, and filtered into urine as 5-hydroxyindole acetic acid. Now we'll start with metabolism in details. Now there are two pathways for the breakdown. One is serotonin pathway, another is kynurenine pathway, right? So first of all, we start with kynurenine and thranilate pathway, right? So students face great difficulty in learning this pathway. So I have made a story out of it so you can remember it very easily, right? So remember that there is a kingdom named Tryptophan, right? And in the kingdom of Tryptophan, there is a king, K for king, and K for kynurenine, right? And his son's name is Anthracycline, right? So in the kingdom of tryptophan, there is a king known as Kynurenine, and his son's name is Anthracycline. So we'll start with the story. So first of all, there is kingdom of tryptophan. So we'll start from tryptophan, right? So tryptophan undergoes reaction by tryptophan pyrrolase to form and formyl kynurenine, right? So this reaction is induced by, right? So this reaction is induced by corticosteroids, right? Corticosteroids, right? So it will start breakdown to form N-formyl kynurenine. So remember, I told you that kynurenine is the king. So now this is N-formyl kynurenine. So it was a former minister in the cabinet. After the election, he became king. That is kynurenine, right? So this was N-formyl kynurenine. It is now converted into the king. That is kynurenine. So there was format was there. The format days election will proceed, and format is removed from here, right? Format is removed by format days, and format is removed, so we get the king, that is Kynurenine, right? And now the king, that is Kynurenine, suffers from diabetes, right? And he have lot of stress, right? But he is continuously increasing his kingdom, that is tryptophan, in various continents, right? So the kingdom is being increased, but he is having diabetes and stress, so he used to drink a lot of water, right? But in order to increase his name and fame, he was drinking a lot of water, so the name and fame was further increased and spread across continents. So the name is 3-hydroxykynurenine, right? Kynurenine is the king, and when the name and fame spread over various continents, the name became 3-hydroxykynurenine, right? Now, I told you that Kynurenine is the king and Anthranilate is the son, because his name and fame spread around various continents. 3-hydroxykynurenine, he wants to take retirement, right? So here comes the enzyme kynurenase, right? So kynurenase breaks down kynurenine from here, and it comes out. So he handed over his power of attorney to his son, that is anthracycline. So 3-hydroxykynurenine was there. Kynurenase breaks down kynurenine from here, and he handed over his power of attorney to his son. So he came into power 3-hydroxyanthracylate, right? So it is clear now. Now this is the son, that is 3-hydroxyanthracylate, right? So this son is now enjoying the name and fame. but he is a spiritual person and he is doing meditation 6 hours daily, right? So after 4 or 5 years, he got self-realization that in my kingdom, these people are suffering from a lot of diseases, right? So he wanted to pursue MBBS, right? So he started waking up at 2 a.m., right? 2 amino, 3 carboxy, and used to take 3 cups of tea, right? To study MBBS seriously. So the name is 2 amino 3 carboxy muconate semi-aldehyde, right? 2 3 carboxy muconate semi-aldehyde. So the prince who became king, 3 hydroxyanthanolate, after meditation for 6 hours, he left his kingdom and started doing MBBS, right? So he used to wake up at 2 a.m. used To activate his brain, he used to take 3 cups of tea, 2 3 carboxy to study MBBS seriously, right? 2 3 carboxy muconate semi-acid. Now he is doing his MBBS and waking up at 2 a.m. and taking 2 cups of tea, 3 cups of tea daily, right? Now he has 3 options now, right? After the name of the kingdom was Tryptophan, the king was Kynurenine, the son was Anthranolate. Now he is doing MBBS by waking up at 2 a.m. and studying, taking 3 cups of tea. Now, the 3 options are that first of all, it can undergo picolinate carboxylase reaction, right? So it will be converted to picolinate, right? And it can also undergo spontaneous reaction by hydroxylation, and it can be converted to quinolinate, right? Quinolinate will further gets converted to NMN, right? And NMN is further converted to NAD, and NAD can be further converted to NADP positive, right? So we got the two niacin derivative we discussed earlier, right? And there is another pathway. The third option for this is sun is to undergo decarboxylation, and this is decarboxylation reaction, right? So 2 3 carboxy muconate semi-aldehyde, the carbonic acid is removed, so it will form 2 muconate semi-aldehyde, right? And it will further form butyryl CoA, right? And butyryl CoA will further form acetyl CoA, right? And acetyl CoA can enter TCA cycle, right? Now the second pathway is serotonin pathway. The earlier pathway was kynurenine and thranylate pathway. The second pathway is serotonin pathway. That is the major pathway. So in order to remember this, remember the pathway of synthesis of epinephrine, right? These reactions will proceed in a similar manner, right? So first is tryptophan, and here is tyrosine, right? Tyrosine is para-hydroxyphenylalanine. So tyrosine undergoes hydroxylation reaction to form dopa para-hydroxyphenylalanine, and now this is dihydroxyphenylalanine. In the similar manner, tryptophan was there, and we introduced hydroxylase reaction to form 5-hydroxytryptophan, right? So this is a tetrahydrobiopterin dependent reaction. It is converted to dihydrobiopterin, and the reaction is carried out by tryptophan hydroxylase, right? So in the second reaction, we got 5-hydroxytryptophan, and we undergo decarboxylation, right? So this is decarboxylation reaction, right? So we'll remove carbon dioxide, and 5-hydroxytryptophan is converted into serotonin, right? That is our happiness molecule, or it activates the brain, right? And serotonin will further undergo acetylation by acetyl CoA to form N-acetyl serotonin. The acetylated serotonin is known as N-acetyl serotonin, right? And to proceed further, we'll add methyl group, right? When methylation is done by methyl donor S-adenosyl methionine, and is converted to S-adenosyl homocysteine, and we'll get melatonin, that is our sleep molecule, right? And in order to how it is removed from the body, it is undergoes monoamine oxidase reaction to form hydroxyindole acetic acid, right? And hydroxyindole acetic acid is further split into urine. So comparing the two pathways to remember tryptophan pathway, first reaction is hydroxylation reaction, same as this. Second reaction is decarboxylation reaction, the same as this. And then serotonin was further acetylated to form N-acetyl serotonin. It undergoes norepinephrine to epinephrine methylation reaction. In the same manner, adenosine methionine to adenosine homocysteine to form melatonin, that is our sleep molecule, right? And to excrete it into the urine and degrade from the body, it undergoes monoamine oxidase reaction to form hydroxyindole acetic acid, and it is secreted in the urine. So this is the pathway. Two pathways are there: kynurenine pathway and second was serotonin pathway. So in the next video I will discuss the disorders, and please like the channel, subscribe the channel, and don't forget to hit the like button below.